Hello, my dear students. It's discipline Introduction to Aerospace Engineering or Introduction to the Major, depends how you prefer to call it. My name is Svetlana Mironova. I am Senior Lecturer of Aircraft Manufacturing Technology Department of National Aerospace University, Kharkov Aviation Institute. Now, after I have introduced myself, I should introduce maybe the discipline as a whole. What we are going to talk about during these studies, we need to talk about not even fundamentals, but basics of aerodynamics, of flight dynamics, of general matters of aircraft design, about history of aircraft, about history of flight at all, and about manufacturing as well. Actually, idea of such a discipline in our curriculum that at the first year, when you're first year students, you are not separated, you are not split onto specialization. You are all studying according to the same curriculum first 2 years. But during these 2 years, you need to select, you need to decide what your specialization will be in the future. Either it comes about aerodynamics or about aircraft strengths or about aircraft design, airplane and helicopter design actually. And last option, last but not least, manufacturing. No, me is lecturer of manufacturing department, but I have graduated from design department. So whatever we are selecting next, all these matters, they are intertwined, they are so close that next you may change your specialization, of course, somewhere in the future. So don't be confused with this. And idea of the discipline is familiarizing you with these different fields of aircraft engineering, of airplane and helicopters, better to say engineering, in order you may choose what next will be your individual studying profile. Now, as far as I understand, you already don't need it. You have already maybe selected your future somehow. So you don't have to pick up to select which department will be your native department next. And idea of this course to you is first idea, the very first idea of any student is to have a pass. How you may got your pass, how you may get your score. According to rules in our university, usually we have half of score up to 50. You may get it during the final tests, examination or test, whatsoever. And 50 you need to deserve during the studies, during the semester. So you will have, at the end of studies, you will have 2 tests. Look here in our mentor, you might find them. Of course, right now they are not available for you. Each test, 25 questions. One test you might see practically about everything, about aircraft flight history, flight theory, aircraft design, and so on. And another one is especially about the aircraft manufacturing, aircraft technologies, aircraft manufacturing technologies. And each test contains 25 questions. It's so-called multi-choice test, multi-choice option test. So you may select one of options. In case you did it correct, you have got plus 1 point to your score. It's 50, maximum 50 points. As I said, it's your final examination. And during the semester, during our practical classes, we will do some tasks. For you, it takes time, of course, but I promise it will be not much difficult. And I hope it will be somehow interesting for you. Right now, let's start our studying. And traditionally, first, when we study this discipline, when we start talking about flying vehicles, about flight, we start talk about flight principle first. What we understand as flight principle, let me to show you. Time to time, I will show you different things in internet, in my books, and so on. Now, of course, I have lecture slides, but time to time I need something more immediately, what by surprise to myself. Look, what we understand as flight. Flight is a sort of motion, and it's such a motion that may be in some fluid. What we understand as fluid is it's not compulsory liquid, no. Um, so it's some motion in air, fluid, or it's maybe motion in vacuum. The main restriction of such motion, in this terminology, that it's motion without any contact to the planet's surface, whatever planet surface. So flight, it's some motion without contacting with, no, in our case, with the Earth. But why things may fly? What what keeps them in the air? Well, mostly we'll talk about air, of course, because your specialty is not rocket design. Your specialty is aircraft, airplane and helicopters design, as far as I understand. So what keep things in the air? Lift. What we understand as lift. A lift is a sort of force which counteracts gravity and help you keep these objects in the air. Now, once again, remind you, mostly we're talking about vehicles, so about mechanical objects. And right now you see the picture, this one non-colored, or here is the same. Oh, sorry. Actually, I'm trying to do it already for sometimes, but each time something or someone interrupt me. I was unlucky today. It's approximately fourth time, but when I try to do it. So you see separation, all the aircraft, all the possible variety of aircraft onto four groups. How this separation happen? Actually, it comes about nature of the lift. Time to time we will use something like blackboard, whiteboard in our case. And here you see flight principles divided onto four groups. What should I say first? First two of them, they are conditionally statical. What does it mean statical if it comes about motion? It means that they have no propulsion force. Such aircraft, such flying vehicles have no any propulsion force, which permanently supply energy to continue the flight. What about these two principles, rocket dynamical and aerodynamical? It means that on board of aircraft you have some aggregate, you have some device which provide permanently propulsion force, pushing force. In case of ballistic and aerostatical principles, there are no pushing force. No, seems like permanent pushing force is absent. And in case of dynamical principles, you permanently have some pushing propulsion device on board. Do continue with the first principle, ballistic one. And what we understand as ballistic principle, you already might see. Actually, it comes about so-called projectile flight. Uh, it means that something was thrown, something that might have or might have not any additional devices which help to fly. No, it's maybe not quite clear what did I say. What maybe I should say since beginning. I know that you already no, not first years, and you have studied already in your universities. I'm not quite sure what specialty you are and what you have studied, but things may be already familiar to you, that what I'm trying to explain right now. They could do pay attention that a flight principle in clean way, what in pure way. Yes, some aircraft they really work according to that or another flight principle without mixing with another one. But some vehicles, some types of vehicles, they actually use simultaneously combination of some principles. So what do I mean that ballistic flight is not compulsory clean ballistic clean projectile? We may imagine what it looks like when someone, no, for instance, the gun, when gun shooting, someone thrown some object, or gun shooting, and due to this we have motion of object, which was initiated, which was forced, started with some initial force, some initial impulse. And we need each time to talk about what forces act to the object in flight in order to understand differences. Actually, where lift, how lift may appear if we throw something. Now, you know that object. Oh, sorry, I'm so awkward today. Let's imagine that we have, for instance, a ball. For instance, a ball. Great. Thank you. Let it be we have ball, and to this ball we apply the force. Force, oh, original force that you have applied, maybe with some angle with respect to the horizon. But here is some original force, P0, looks like this. Maybe I did it too much, too big. And how lift appear? No, we understand that such vector of this force, original force, it's maybe better maybe to call it F, not P. It's maybe splitted onto two components, and one component will be directed immediately to the top, and another one make this object move front. Oh, do forgive me, I draw wrong value of our forces until I was thinking what color to choose and how to do it brightly, understandably, and less ugly. This picture, I did wrong value of force. So what here is decomposition of the sector onto two sub-forces. Lift, traditionally we designate as English letter Y. And here is this pushing force, which was applied once. No, to this pushing force, better, of course, to give name. It's force P. But this P is permanently reducing. Why? As only you throw this object through the air, as only its start motion through the air, as air has inner friction with this object, you subjected to one more force in this case. And this one more force, no, let it be, it's no idea which color, in back side, in back direction. This force, traditionally designated as letter X, this force is called drag. So lift, drag, and force that start pushing object to the front. And why doesn't fly away at all somewhere in space? Because something counteract, no? And this something is gravity force. Gravity force directed to the Earth, directed to the center of Earth. So we see seems like four forces acting to the object, but to be frank, as I'm already said, this one, this one, actually it's gradually, permanently reducing, it's disappearing. No, the same thing we might see in we we should see, but it's not quite like this shown in the picture. That here this force seems like acting permanently with the same force, but actually it's permanently reducing because it's counteracted with the drag, and this drag like it's erasing this initial force, and due to this, what happened? You might see object does not fly permanently; it does not continue the flight. Object reduce this it's like span this initial force, and due to this initial force became less and less, and as a result you have what actually picture is very beautiful but not completely correct, and as this force is permanently spending to the counteracting both to the gravity and to this drag force, it's reducing, and quite clear uh, object at some moment it's just uh, coming back to the Earth. So this ballistic flight, once again, in the plainest words, it's flight due to the throwing of object, due to some initial portion of object. And actually, we should say that it's only three forces acting during such a flight. Why? Because permanently we have permanently acting forces, only three forces. What you might see right now, it's illustrated in a slide of NASA Research Center. Have no idea what segment of internet is available for you, so if it's permitted, I'll show you all the links to such things. No, if not, do forgive me, it's not much, not even interesting, but not much important. You may read there all the books. What if you see, I have opened half dozen of books to you, being preparing to these classes, and these books they are rather similar. If we start scrolling them, we might find similar things, and actually sorry, it's not much illustrating my words and similar things. You have already seen half dozen of different things due to me. No, it's when you will if I hope you open those books, you make sure in my words that those books contain very similar information, whatever they are, uh, and such information may be arranged in different way, but mostly it comes about the same things which I explained by different words. And as for me, your task will be when you are reading the book, maybe to select at least more convenient book for you, to select the book which is more understandable, more convenient for you for reading, because we are all different, and everyone may be interested in different aspects. Let's say in those books. Well, to forgive me, let's continue immediately studying. Да? Once again, when we're talking about ballistic principle, it comes about no permanent propulsion force. We have lift which appear as result of decomposition of initial force vector, and due to permanent presence of gravity and due to appearing of additional force which counteract the motion drag, Due to appearing of all these forces, object flight according to parabolic trajectory, and the exact shape of this trajectory, it might depends on what it depends on. Of course, it depends on initial force above the wall, and second, it depends on no, when I say what flight depends on, I mean which parameters of this flight. Of course, range of flight above the wall, range, attitude, no, and speed of flight either. No, above the all, what is the range and attitude of such a flight? Of course, it depends on the force. Of course, it depends on force, it depends on object weight, but also it depends on the angle of deviation, initial force deviation to the horizon. You see here the illustration to this idea. What type of aircraft realize this principle, ballistic principle, in clean way? Actually, in clean way, we might say that it's only about the satellites, about the no, we may say that about kites either. But not quite, because kite is already combination of some principles. Why? Because kite have some intertwining with aerodynamical principle. So when we see satellites, we understand that it comes about this ballistic principle. And according to this ballistic principle, whatever flight is, once it's appearing again on the Earth, this object, this vehicle. Don't be confused, don't be deceived with such names. What, for instance, here, ballistic missile, так? It not compulsory that it's really flight according to ballistic principle. Ballistic missile, it's called ballistic missile, but really it realizes combination of two principles. During flight, first, it's some piece of the way it goes according to the rocket dynamical principle with engine, and at some moment engine let's say disappeared, and engine is switched off, and next it's really follow to this ballistic projectile trajectory. What in other devices realize ballistic principle, but be attentive, it's already combination of principles. What, kites and gliders, so-called hang gliders. Uh, you see, what glider as a whole, it's very similar to the normal airplane. What does it mean normal? No, seems like airplane with a wing, with empennage and so on. And hang gliders you see in this picture at the top. Also, both of these types of aircraft, they have no any propulsion force permanently renewing during the flight, besides of this initial force due to running of the pilot with this hang glider, or or due to the running of the pilot with the airplane as a whole. No, it's maybe started somehow with additional devices that enforce it, push it to the flight, but not in this beautiful case. We see what is the real propulsion force, what initially gives the force to the flight to this aircraft. Once again, remind you, very similar to the airplane, but not airplane. And this airplane seems like airplane, it's called glider, this type of airplane. With this so-called delta wing, with this triangular wing, we also, it may be hang glider, or it may be delta wing airplane. Very similar, but this delta wing airplane will have engine, propulsion force permanently supplied. But both of these gliders, hand gliders, they use combination of principles. They have additional device which help you to continue the flight. Besides of initial force you applied, they also have wings. Wings, surfaces of special shape in cross section, which uh, give you additional lift. No, that will be later the matter of our consideration. No, just do remember that they are of combined principle. And one more type of aircraft, kites, which originally, as I was said not once, and as I read, originally has appeared exactly in your country, in ancient China. And actually, when we start studying the history of commercial aircraft aviation, using of aircraft for commercial purposes, for commercial or for military purposes whatsoever, first it comes about kites. Kites been used in China as no signal system, as for transporting of something, not just like entertainment, like it might be right now, but also why it's not. No, seems like we have only very beautiful. We also have only three forces, да? So it seems like it's correspond to ballistic principle, but because it's not stiff, because surfaces of kites they are not stiff, they somehow imitate the airfoils, the special shape that's typical for wings, and this special shape help to continue the flight, to uh, make flight longer. Так, next one. Next principle will be aerostatical principle. Once again, we have something. We have something, and this something we need to push, no, somehow to make a flight with the something. Look, in case of ballistic principle, aerodynamical, rocket dynamical principle, whatsoever, it comes about bodies which are heavier than air. Whether they have propulsion system or not, they are heavier than air aircraft. When it comes about aerostatical principle, they are called lighter than air aircraft, those aircrafts. But how it may be? Maybe it's something so thin, so light that can be used for any purposes in real life? Not, of course. These aerostatical aircraft, they are represented usually the first ever thing that comes into our mind. Of course, it comes about these beautiful things, air balloons, and this aerostatical principle is realized for these air balloons for transportation of heavy loads, of heavy cargoes, or at least for transportation of people. And people certainly they are much heavier than air. So how it may be that aircraft is lighter than air? Certainly it comes about the whole average density of this aircraft together with payload, together with people or cargo. It will be a little bit lighter than air. And then due to the buoyancy force which push out the aircraft or whatever object from fluid, until we don't have some balance between force of buoyancy which push the object up and force of gravity which pull the object down, it may flight up. And quite clear that in order this average density became less than air density, the size of the aircraft, the overall dimensions of the aircraft should be huge. They should be much greater than objects that they are going to transport. And this huge additional volume, it should contain some fluid or gas which might lighter than air, which has much less density than air density. Usually, right now, we use these air balloons of Montgolfier type. But no, not right now. I will explain it. But I need you to remember that there are some different types of air balloons, and some of them they are of open type, like this one. It's open air. Да? They use just warm air inside, and warm air is lighter than cold air, and due to this they are able to fly. And there are so-called charlier type of air balloons. They have closed volume, which typically fill it with some gas which much lighter than air. For instance, it comes about hydrogen or helium. And there are combinations, so-called Razier type of air balloons, which use both variants, open air volume and some closed volume, which has gas lighter than air. Let's talk about forces which acting in flight to such aircraft. We forces. Well, now let's draw here additional volume first, just symbolically, in order we might remember it comes about aircraft of certain type. And to start once again, first we have gravity. Each time gravity we have. Second, we should have lift. Lift actually it's in this case it's buoyancy force. What it depends on, let's see in some seconds. And what about the horizontal forces? How horizontal forces may appear. No, I understand it's not a surprise for you. You might be already understood. There are no horizontal forces. No permanent propulsion force, as I said. No propulsion system. In case we're talking about clean aerostatical principle, when we have only buoyancy force that push aircraft up, no horizontal forces. It means that this aerostatical vehicle is able only to climb and decline, to move up, to move down. But it's not the whole truth. The truth is that actually we have something like flow of air in the atmosphere, and this flow, this winds or air motion, because of different factors like no, for instance, in mountains we have no, over the mountains, let's say. Да? We have cold areas of air, we have the ground which warm it up with sunlight. Due to this appearing some vortex, so-called thermics of air. Uh, Somewhere, no, for instance, different climate, different weather. Somewhere we have different area of atmosphere pressure. Also, now as a result, appearing some motion of air, and we might use this motion of air and also have some horizontal flight. In this case, of course, drag will appear. Of course, some drag appear, but theoretically, this aircraft is able only to climb and to move down. So this aircraft seems like aerostatical, clean aerostatical aircraft seems like has no any commercial no purpose, any commercial profit. I know some ability of using of them. Now, of course, it's not true because they have such modern devices. They have additional valves in their design, in their structure, and these additional valves, they are able to change position of this balloon a little bit in air, and due to this, it may change direction. So somehow they are already controllable. What is about buoyancy force that is responsible for appearing of lift in this case? No, you know, maybe one more time remind you, I didn't say it yet. This principle, it has double name. It's also may called Archimedes principle. Archimedes principle or Archimedes force, buoyancy, which equal to the weight of displaced fluid. Once again, remind you that fluid, it's not compulsory liquid or some water or something like this. Uh, Fluid we may understand as any gas. And what it's necessary, let's say, how to increase this buoyancy, да? What is necessary to do? To make object as much possible great in size and lighter than the fluid that surround it. And due to this, we have, you see, appearing of this additional force which pushing the object out of this fluid or to some another layers of the fluid at least. Why I'm talking about another layers of the fluid, I didn't explain it yet, but I'm quite sure that you have no whole idea about so-called standard atmosphere. Next, we will also maybe talk about a little bit. You know that atmosphere, the parameters of atmosphere near the ground and on heights, it's completely different. That we have some layers of atmosphere with different pressure, with different temperature, and so on. So when it comes about aircraft that uses buoyancy force, actually it may fly up only to some level until this buoyancy force, even with the oversized this additional volume, will be balanced. It will be completely no, defeated, let's say, with the gravity, да? Because the higher, the less is buoyancy force. With the same size of aircraft, with the same volume of this balloon, the higher, the less buoyancy force because density of air is less on the heights. And here you see a very understandable and very simple demonstration of buoyancy force in this slide. How it's act? You see some scale with two equal spheres which are in balance right now. And to the one of these spheres, it was placed empty glass. It's yet empty, and scale it's still balanced, as we might see. And as only it's added some liquid to this glass, what happened? You see, scale is disbalanced. Seems like this sphere became less in weight. No, it can't be. Yes, it's not less than weight, but it just demonstrates appearing of additional force. The liquid pushing up this object with the force which equal to, you see, to this volume that is inside the liquid. Well, once again, such a craft may climb, may descend. That's it. Seems like, no, in order to defeat this problem, at the beginning of 20th century, has appeared combination of aircraft of this type, aerostatical, and aircraft with propulsion force. You know very well, I trust, such type of aircraft. They are so-called dirigibles. They are also maybe called airships and blimps. Let's see these names. Sorry, nothing is visible yet. Just to show the beautiful picture to you. And names once again of them. No, not sure that it will be much visible to you. Wait a second. Here is the dirigibles, airships, blimps. Actually, it comes about the same vehicles, but due to different reasons, they might have different names. No, right now you see that everything is disappearing in the screen. Don't touch mouse, and in this case, we might see something. Right now, you see rather similar design, no, as for first sight, no, very similar design of these dirigibles or blimps of airships, however you may call them. And not far from them, you might see demonstration of two types of air balloons. On the right, with vertical strips, it's Montgolfier type, and with open air balloon. And on the left here, it's so-called Charlier type, after the name of those who has invented them. And this balloon has closed camera, closed volume with gas which is lighter than air. What sort of combination, as I said, above the all, dirigibles, blimps, airships, they have engines. Whatever type of engine they use, uh, they have engines. Engines supply permanently propulsion force. Due to this, such vehicle able to have directed flight. Of course, they are huge comparatively to what we get used to see in our airports. Of course, they are very slow, but when they appear, they were a solution, and the best solution seems like for that time, for beginning of 20th century, for long distance travels, especially when it comes about over ocean, between continents travels. And they were in wide use during 20, 30 years at beginning of aviation age. Let us to see the next slide. What did I say already? It's comparison of size of the most known airship dirigible. You see the name Hindenburg, with the most known modern, the hugest modern airplanes. To pay attention, what you see as little spot inside of this dirigible. It comes about the Boeing 747, A380, our Antonov 225 Mriya. No, you see, да? Comparison of hugest cargo or passenger aircraft no, of nowadays with this dirigible, which has been in use already over 100 years ago. Certainly, these airplanes, hugest airplanes of nowadays, they just disappear in this size of dirigible. Once again, they were in very wide use. Do pay attention to these photos. No, do forgive me for this piece. It's because Hindenburg, it was aircraft of Germany, and quite clear that they have in historical photos and historical pictures they have here this sign of fascist Germany. No, at least we see schemes and real photos made on board of this Hindenburg. Do pay attention that what it looks like. No, practically all the airship is empty. And do pay attention to this photo on the right at the bottom of picture. What do we see, guys? Restaurant. May you imagine something right now like this in the airplane? Seems like normal full-scaled restaurant. And moreover, on board of this Hindenburg and other dirigibles of these types, so-called Zeppelins, by the name of owner of company who provides the slides, they have bedrooms, they have restaurants, they have resting rooms, no, whatever they have, maybe besides of pool, да, for swimming pool, I mean, for passengers. So it was the whole city, maybe, no, at least luxury village, let it be, at the bottom of this dirigible. And all other area, it was filled with some gas, which lighter than air, and this gas was hydrogen, or at least mixture with hydrogen. And one by one, this dirigible, they have unpleasant incidents during the flight or during the landing of these vehicles until it's not happen no real tragedy. Again, you see real historical photo. I'm afraid you heard about such things already. Uh, what that dirigible that we might see exactly in these photos, it was crashed. By now, it's people yet arguing about what happened exactly. But more probable that during the landing, uh, this airship no, occasionally touched the so-called matched the something like you see now something like tower for no for anchoring, let's say, of this dirigible. If this aircraft is lighter than air, how it may land? It's lighter than air. In order to take land to take off, it's quite clear. It just when it's not fixed, it just move up. Да? Next, it start engine and start motion. But how to land such an aircraft? It's lighter than air. It's not about to land actually. In order to make it land, people pull it to the ground, and somehow it's similar to appearing of a real sea ship to the port. They have ropes with anchors, and they just throw these anchors, no, like throw it down to the ground. Those who receive it at the ground, no, the people, some team who responsible for landing, to collaborate with dirigible crew, they pull it these ropes to the ground and they need to fix it. And these masts, they are something like huge stadium, and they have these stands, as you might see, in order to fix this airship to these structures. But maybe because of occasional touching of this structure, maybe because of some um electricity, statical electricity over the skin of the dirigible, whatever reason was, but it was exploded because you know that hydrogen, when it's contacting with oxygen and air, it's almost quarter of air is oxygen. As only hydrogen move out this skin, move out this balloon, which actually, no, you see, the volume is unbelievable, really, the size of this balloon. And as only hydrogen contacted the air, it's uh, blowing, it start fire, and really it was crushed and it was disappearing in front of people who collected to meet it. It comes about hundreds of people who came to meet it because at that time it was great show appearing of this dirigible flight over the ocean more than a couple of days and so on. No, great event actually. Do you imagine no television, no smartphones, no entertainment, no much entertainment, and appearing of this dirigible somewhere in New York. It was very interesting show, and of course, you see what happened once. After this, what that is what like last drop. After this dirigible was out of use at all for years, for ages, let's say. The only use of dirigibles, but not even dirigibles in clean way, some air balloons which similar to dirigibles, was during the Second World War, and they've been in use especially for protecting the area over the cities against the enemy airplanes, but they were out of commercial use for ages, really. But now they are coming back. Why? Once again, they are able to transport huge cargoes. Yes, they are slow. Yes, they are huge in sizes, but they may transport cargoes practically without much fuel, so they are economically efficient in this meaning. And perspective of such type of device, it's very interesting both for passenger transportation and for cargo transportation. Now, right now you see I placed here some no funny photos on purpose, of course, you understand. Huh? Right now you see attempt on the left. It's Lockheed dirigible, if I'm not mistaken. As I used to say, you see, however interesting they are still the same reliable. What on the right you see photo of, it's not a crash, of course, but it's some undesirable type of landing. Now, once again, it comes about aerostatical principle, and this aerostatical principle which use buoyancy force in clean way, air balloons of different types, in combination with engine, it's maybe dirigible, as we might see, which has long and gloryful history actually in their use. And no, practically that's it about aerostatical devices. Next one, rugged dynamical principle. Now, here is, on one hand, seems everything is very simple. On other hand, somehow it's similar to what we have already seen in case of ballistic principle. Let's try to move the board. No, and in order to show that it exactly a rocket, we will draw something more similar to the rocket. Not much similar might be. No, at least I tried. What about forces? No, once again, now always we have gravity force again. And now we have permanent propulsion force. Now engine has appeared. Engine, no, actually it usually this rocket engine, it's throughout some volume with very high speed, some volume of no, little bit some mass of rocket. It's like thrown back from rocket, and because it's made with very high speed, the rocket as a whole, the last of this mass, may move in the another direction, in counter direction, and it may move, of course, not with not such high speed. It's so-called principle of impulse moment conversion. Force acting here, propulsion force. Now it's permanent force, not like it was some zero force. And this force now, it's let's show it like this. Also, it's decomposed onto horizontal and vertical force. Vertical force, push object up, vertical piece of this force, it's our lift. Horizontal force, actually, no, let's call it Px in this case. Ой, Px, x is the drag, да? K, Ph, horizontal. Ой, sorry. Horizontal component of the force. Responsible for motion in horizontal direction, and of course what happened once again, drag has appeared. Drag, and in case we throw this object, in case we move this object in the air, drag is not zero, quite clear. In case you are in vacuum, of course this force is absent. So rocket dynamical principle, once again, in clean way, it comes about, where is our slide? It comes about rockets, of course. Whether it comes about space rockets or it comes about missiles, once again, remind you, it comes about the motion due to propulsion force, and this propulsion force, if it's directed not ideally vertical, decomposite, it's split onto two forces. One, move object up vertically, it's lift force, not quite like in NASA picture, more similar to this picture. And in case, once again, this pushing force, it's not completely directed up, we have horizontal motion. Now, I'm already called sometimes red force lift, weight gravity. I forgot again to show this vector sign as a rule. Drag, it's counteracting of fluid that you are flying in. And one more force is force of thrust. Engine give us force of thrust. Так, and this picture is to illustrate, no, it's just illustration really to this idea of conversion of moment, impulse, impulse moment conversion principle. Look, in case we have two rollers, what do you imagine? They are really on rollers. In case we have two rollers of equal weight, and if they push from each other, both of them move, and both of them move to the equal distance. Do you imagine that one of these rollers, it's not of the same weight? For instance, it's mother and a child. Child, of course, sometimes less in the weight than mother. And do you imagine that they are pushing each other with the equal force? What happened? Mother, more probably, practically does not move, stay on the place, and child will just fly away to some meters because of this push. How it's happened? Once again, little mass, big speed, and less speed because of big mass. That is like idea of rocket dynamical principle, that practically flying vehicle is throwing out some portion of its mass. It's fuel, which of course it's burned in the engine, and this fuel is creating additional force, jet type of force. And due to this, because this jet force, it's like pushing rocket. No, it's throwing back and pushing rocket to the front, horizontally, with along the axis, horizontal axis to the rocket. In case, once again, it was directed not completely vertical or not completely horizontal, this force is splitting, and as a result, it's appearing the lift. That is idea of this rocket dynamical principle. Так. Last principle also has double name. In this case, it's name of Switzerland scientists. They are all called physics. Actually, Newton was physics. They are all considered like studying the physics because there were no splitting, separation of science into some subfields, let's call. And in 19th, 18th century, all them called physics. So one more principle, aerodynamical principle, it's principle which realize so-called Bernoulli principle. And what is this Bernoulli principle about? Actually, he studied this Daniel Bernoulli, this Switzerland scientist. He studied not really the flight. He studied flow of liquids, and he has provided the experiments to study some effects of liquids in pipes, and he has noted a very interesting effect where the liquid, no, you see here demonstration, the pipe of different cross section, where the liquid has higher speed, manometer joined to such a pipe, manometer device show pressure. Where speed is higher, pressure is less. Where speed is less, pressure is higher. And when Bernoulli, Daniel Bernoulli, it was the whole glorious family of Bernoulli scientists, when Daniel Bernoulli studied this effect, he has write it as a law, as a principle in mathematical way. What we will do right now, we will interrupt for some minutes. I will interrupt the record, and after this interruption, I will continue about aerodynamical principle.